和大家通报一下印度的月船3号的事儿。概括的说，就是死了；详细的一点就是冻死了。本来印度的原计划是，飞船所在的月球南极区进入极夜以后，它进入休眠状态，因为进入极夜以后，它那地方温度太冷，它就休眠了，这个电子元器件就无法工作了。原计划是出了这个极夜以后，它再醒过来。这有点像我们地球上的青蛙呀、狗熊之类动物冬眠，然后冬眠完了再醒过来。可是呢，因为它这个月船3号的这个保温和加热系统它没设计好，也可能是因为月球的南极地区的极夜比它想象的更冷，所以反正就直接冻杆了，再也醒不过来了。
The lander Vikram and rover Pragyan faced the ultimate test of lunar night without any heaters. To understand this lunar challenge, it's important to get back to the basics and see how the heat would be lost by lander and rover. For heat transfer to happen from any body, conduction, convection, and radiation are the only three modes of heat transfer. The possibility of convection on Moon is ruled out as it relies on the movement of fluids. But on Moon, there is no atmosphere like Earth to enable transfer of heat in this way. In conduction, heat is transferred through a material or between materials due to direct contact. The rate of heat conduction depends on the temperature difference between the regions, the cross-sectional area through which the heat flows, the length of the material, and its thermal conductivity. JAST, that was one of the scientific instruments on lander, gave an idea about the thermal conductivity of Moon's surface. It measured the temperature of the lunar topsoil to understand its thermal behavior. See how the temperature varies with depth as provided by JAST payload. Notice how the temperature on Moon's surface at 60 degrees Celsius becomes minus 10 degrees at just 80 millimeters below the surface. This indicates a low thermal conductivity. And therefore, the conduction of heat from the bodies of lander and rover to the Moon's surface can also be taken to be quite low. Now the spotlight turns to radiation, that is also the only crucial player in lunar heat transfer. Even in extreme cold, objects emit infrared radiations based on their temperature. So the lander and rover would always be at a higher temperature than outer space. So most of the heat from them would be lost through radiation into the space and some of it also to the lunar surface. Based on the data from the past Moon missions, for any spacecraft to survive lunar night, it needs to have three important things in place. Number one is a heating source to keep it warm. Number two is a well-engineered insulation to cut or reduce the heat transfer to a bare minimum level. And number three is a cryo-suitable electronics that can handle fatigue from thermal cycling arising from temperature falling and rising to insane levels during lunar nights and days.